Okay guys, in this video we're going to talk about quantum numbers. And a quantum number is a number that specifies the orbitals of an atom. So what is an orbital? It is the region of space in which a pair of electrons could exist. And we say could because remember that it's super duper hard to locate an electron because it's moving so fast. So you have some different quantum numbers here. The first is the principal quantum number. Those are numbers assigned to the main energy levels surrounding the nucleus. So when you were in physical science or when you were younger and you drew atoms, these would be the rings that we're talking about. And a principal quantum number is symbolized by the letter N and their whole number values. So the values are going to be like 1 through 7 in the ground state. And ground state just means that the electron is normal. It doesn't have any additional energy added to it. An orbital quantum number is going to indicate the shape of the orbital. And they're also called sublevels, if you've heard of that before. So they're going to be symbolized by S, P, D, and F, those letters. And each letter stands for a different shape. So S is a sphere. So this would be an example of what the S orbital would look like. The electron would be found somewhere in that sphere. And then the P, you could be called a dumbbell or a peanut shape. This is what it would look like. And the electron would be somewhere in that. Now notice the dumbbell or peanut could be on different axes. So it could be in different positions, but the shape would still be the same. And D is a clover or a double peanut. So it's going to look like this. So you're going to have basically two of those peanut shapes crisscrossed to look like a clover. And again, they can be on the different axes as well. And finally, the F is called a flower. And basically, it has the little peanuts going in every which direction. So here are the different orbitals, all comparative. So we have the S orbital, which is a sphere. The P orbital, which is the peanut or dumbbell. The D orbital is 2 of these put together. And then the F orbital is 3 of these put together. So now we have a spin quantum number. And what that means is it's going to be the spin of an electron. So which way literally the electron is spinning. And each orbital can hold 2 electrons. And it's going to be symbolized by a 1/2 or a negative 1/2. So 1/2 would be going one way, and then negative 1/2 would be going the opposite way. So electron configuration is going to show you where the electrons are inside of the atom. And the way you do this is first you're going to list the principal quantum number, the 1 through 7. Then you're going to list the orbital quantum number, S, D, P, or F. And then you're going to list how many electrons there are in that orbital. Now, I don't expect this to make sense at the moment. I'll show you an entire video on how to do this, okay guys? Now, orbital diagrams are going to do the same thing as electron configuration with 2 exceptions. It's going to also include the spin number, and they're also going to show you exactly which orbitals the electrons are in, the X, the Y, or the Z. So again, one more time, if you're confused, if you have no clue what I just said, don't worry, just make sure you take down your notes, and I'm going to show you in depth in other videos how to do both electron configuration and orbital diagrams.